Hey everybody, welcome back to my channel, Numbers with Nora. Again, we are going to do a geometry video and we are still in chapter 4 and we are going to be doing 4.4, proving triangle congruence by side angle side in the hypotenuse leg or HL theorem. You can follow along using your geometry book or whatever geometry materials your teacher gives. But also I'll put in the comments a free geometry book called Larson Geometry, and also the solutions and answers to the book that I'm using if you do want to follow along with the exact problems I have. All right. So let's start with lesson 4.4. So before this lesson in 4.3, you can refer back to that video if you need to. We were proving triangle congruence using side, side, side. There are going to be other postulates that we go through, but for this one, we are going to sit there and use side angle side and then hypotenuse leg. So remember, for two triangles to be congruent, that means they have to have all the same sides and all the same angles, okay? But we can prove congruency by using our postulates or our HL theorem, right? So let's continue. First off, let's start off with some vocab, all right? So first, a leg of a right triangle. So our leg of a right triangle is just going to be two sides that that intersect to determine the right angle, right? And I'll show you a visual of what that looks like in a second. And then our hypotenuse, which you guys, I believe, have heard before. Oops. Sorry about that. Our hypotenuse, which I believe you guys have heard before, is the longest side of a right angle or a right triangle. Okay. And those are the two major vocab words that I wanted to discuss before we go on with 4.4. And just like I said, I would give you a visual. So when we do create a right triangle, notice we have our two legs. Our two legs are usually like the smaller sides of the triangle. And when they do meet, they create a right angle. And then our hypotenuse, which is our longest side of a triangle in a right triangle, it's going to be diagonal from our right angle, right? And we'll play around more with these in later chapters. All right, so now we're going to come to our first postulate in 4.4. So this one's going to be the side angle side postulate. And how this one's a little different, what you have to remember is, notice our angle right here. Our angle, it's going to be in between our sides, okay? So we're looking for our angle is between our two sides. And usually this is called the included angle, all right? So if we have two sides that are congruent, another two sides that are congruent, and we have an angle in between those two corresponding sides, that means that we can sit there and use the side angle side postulates, all right? So let's go ahead and hop into an example so we can see that side angle side in action. All right. All right, so for this one, we're going to do a proof. And for this one, we're going to do a table proof with statements and reasons. So we're given that BC is congruent to DA and then BC parallel to AD. They want us to prove that triangle ABC is congruent to triangle CDA, right? So before I start writing any kind of proofs, table proofs, paragraph proofs, whatever, I love to sit there and annotate and kind of make like a clear map of what I'm going to write down first or what I can use, okay? So that's what we're going to come over here and do, right? So let's sit there and mark up our givens. We're given that BC congruent to DA. So this is BC. And DA is congruent. And then I also noticed that they sit there and gave us these little annotations as well, the little arrows. Those arrows mean that BC and AD are also parallel, right? So we can use that as well. Now, if we go back and we remember, parallel lines, that means I can sit there and count AC as a transversal. A transversal cuts through my parallel lines. And when I have a transversal that cuts through my parallel lines, they're going to create some angles that are congruent, right? So one of the angles that are congruent from a transversal cutting parallel lines are alternate interior angles. Okay, if you forgot about that, go back in my videos, I think in chapter 3, and it goes over alternate interior angles. So now I know I could use alternate interior angles somewhere. I'm just annotating it down before we sit there and make a nice proof. Alternate angles, just annotating, making notes. Okay. So that's something I can use, right? And that tells me that BCA is congruent and CAD is congruent. Let's look up what else I can use. Ooh, I can think if I sit there and pull these two triangles apart, they share the side AC. This is also a property that we've seen before. So if I mark these, I can sit there and say, I know I'm going to use the reflexive property, because when you have two sides that are exactly the same on two triangles that are touching, those are referred as reflexive. Okay. I'm just going to put reflex right here. So I don't want to spend too much time writing reflex. Okay. So I think we could use that. And so now that I sat there and observed what I had to work with and what they gave me and what I conclude from what they gave me, I can sit there and see I have a side, an angle, an included angle, and another side. And again, a side, an included angle, another side. I can totally use side, angle, side to prove this. So now that we have those markups, let's go ahead and write out our proof, okay? So for one, I'm just going to sit there and write this for sake of time. Usually you always have to write your given. When I write my given, I just usually always write exactly what they have under given, right? So then for 2, let's go ahead and use one of our theorems. We know we're going to use alternative interior angle theorem. So I know that angle, angle, it won't let me write an angle right here. I'll draw them there later. Angle BCA, and I go congruent to angle CAD, and we know this by alternative interior angles theorem. All right. I'm sorry, let me put those little annotations in there because these are angles. I might put those in at the end. I don't think it's going to let me do it. I'll put them in at the end. All right, so that's our alternate interior angle theorem, also reflexive. So I can put that AC congruent to CA. Right. And that one, like we said, because those two sides touch, and we separate those. So those are going to be the reflexive property. And we can put a congruence if we want. Right. And so since we sit there and showed this, we have this side, angle, side with everything. So we just conclude everything. Triangle ABC congruent to triangle CDA. And this is by our postulates. Side, angle, side. Postulate, right? And that concludes our proof, right? Now let me see if it will sit there and let me write in here. Nah, it's okay. I'll sit there and spell out next time. It won't let me sit there and write in the annotations I want to. That's all right. But that's our proof for example 1, right? So let's go on to example 2. Again, we're going to use the side angle side and properties of shapes. So in this diagram, QS and RP pass through the center M of a circle. What can you conclude about triangle MRS and triangle MPQ? All right. So before this one, they're not asking us to write out a full-on proof. They just want us to write down some facts. Okay. So again, before I write down anything, I want to annotate, mark up some stuff, and know what I'm going to write down. Okay. So if I sit there and look at this, they sit there and say that QS and RP pass over midpoint. So by definition of midpoint of a circle, when I go from midpoint to the outside of my circle and it touches the outside of my circle, I know that when it does that again and it passes through that same midpoint, that segment, they're going to be congruent. Okay. So I know that SM are congruent and MQ are congruent. That's just by definition of a midpoint of a circle. And then that means RM and MP are going to be congruent. Again, definition of a midpoint of a circle or a segment that passes through the midpoint of a circle, right? And now I can notice something else about my angle M or RMS and QMP right here. These create a certain type of angle that are congruent as well. And again, we learned that in chapter 3. Those are going to be called vertical angles, and vertical angles are congruent. Okay. So we can sit there and say, by the definition of vertical angles, we can say angle, and you can use the angle sign. I just can't write it on here. Sorry, guys. RMS congruent to angle QMP. Okay. And by definition of mid, I can say definition of midpoint of a circle. I can go RM congruent to MP and SM congruent to MQ. Okay. And again, sorry, I don't have my math thing on right now, but if you did want to sit there and write congruent, you would sit there and write the equal sign with the little squiggly thing on top. All right. For my next video, I'll sit there and have that on. All right. So that explains why MRS and MPQ can be congruent by the side angle side postulates. All right. So now we're going to look at the theorem. So we've been through side, 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 just went over side, angle, side. We're going to look at 2 other postulates, but there is some postulates that we can't use. And usually how I like to explain it is if there's something that sits there and spells a bad word forward or backwards, okay, then it's not a postulate that you can use, most likely, okay? So there's no such thing as side, side, angle, or angle, side, side. If it looks like a bad word, you can't use it, all right? So to make up for side, side, angle, we can sit there and rotate one of the vertexes to become a right triangle, right? And so when we do that, we can sit there and use the side, side angle a little bit more appropriately. And so when we sit there and rotate an angle to sit there and create a right triangle, then we can sit there and identify a hypotenuse and a leg. And so this one, we just want to sit there and see if my hypotenuse matches the other hypotenuse of the triangle. And if one of its legs matches the other triangle's leg, then safely I can sit there and say that those two triangles are congruent, right? But this can only be used when they are right triangles, right? So let's do an example and see what this looks like. Again, we're going to do a table proof with statements and reasons. And for this one, they give us that WY is congruent to XZ. All right. WY congruent to XZ. They give us that. Awesome. Then they give us that WZ congruent to ZY, or perpendicular to ZY, and XY perpendicular to ZY as well. Awesome. So that creates this since they're perpendicular. Like I said, I always like to annotate to make sure I'm not missing anything that they're giving us. So we want to sit there and prove that triangle WYZ and also triangle XZY are congruent. Again, down here, I sat there and separated both the triangles so you guys can see what's going on as well, because these are composite triangles, which means they're stuck together. Sometimes it helps some people to look at them if you split them apart. Okay. But we're doing the same thing. So it's given that these two are congruent. Awesome. Then they told us that these are perpendicular. So first we want to use the hypotenuse leg theorem, but I have to sit there and make sure that these triangles are both right triangles first, right? So since they did give us that WZ and ZY are perpendicular, by the definition of perpendicular, that means that this is going to be a right angle. Same thing for this, it's going to be a right angle. Since a triangle has one right angle, it means they are going to be right triangles, right? They gave us that our WY and XZ are congruent. That's fine. Now for this one down here, see down here, again, down here they're split apart, but when they were together, the YZ and X are the ZY and YZ are right on top of each other, right? They're like the same segment. So that's going to be reflexive, right? So we can use the reflexive. Just note that down so we know we're going to use that. Reflex. All right. So now we have our annotations and we know kind of how we're going to write our proof. Let's go ahead and start writing that. All right. So first thing, you always sit there and write down your given. So one. So we just write down our given up here that WY congruent to XZ, WZ perpendicular ZY, and whatever is given. Okay. Then let's go ahead and use our properties to sit there and show that these are right angles. So I can still go angle Z congruent to angle Y. Again, sorry, I don't have my math mode on, so I can't write the math symbols for them. These are right angles. All right, and this is just by the definition of perpendicular. All right. After that one, let's sit there and then tell them that these are right triangles, right? So we can go triangle, WYZ, and triangle, XEY, are right triangles. Right. And this is just by the definition of a right triangle, because a right triangle has to have a right angle in it, right? Right triangles, right? Now we can sit there and use our reflexive property, right? So we can sit there and say that zy congruent to yz. And this is just by our reflexive property. Okay. So now that I showed that one of the legs are congruent to, and both my legs are congruent, and then also both my hypotenuses are congruent. So then we can sit there and say that triangle WYZ congruent to triangle XZY. Okay. And this is by hypotenuse leg theorem. Okay. And we'll do more exercises on these in 4.4 in the next video I'll do. All right, but that was just like a little taste of it. And then let's do one more example. So this one, we're going to choose the postulates of a theorem. Oh, we don't have to write anything for this. This one won't be that bad. So you are making a canvas sign to hang on the triangle wall over the door to the barn shown in the picture. You think you can use two identical triangle sheets of canvas. You know that RP is perpendicular to QS, which means they create 90-degree angles, and then PQ and PS are congruent. What postulates or theorem can you use to conclude that triangle PQR is congruent to triangle PSR? All right, so I think it's pretty plain out there. Let's see. So they already sat there and gave us that. They do it in green so we can see it. They already gave us that these two sides are congruent. They also sat there and said that this creates a 90-degree angle, which is amazing, cool. But that's going to be my hypotenuse. I don't know anything about RS or RQ, so I can't really say that my hypotenuses are congruent, but I can sit there and say that RP is congruent for both my triangles because of the reflexive property. Okay, so I would say it would be safe to say that I can use side, angle, side to sit there and say that these two triangles are congruent. Okay, so we'd use side, angle, side. All right. Awesome. All right, so that was an introduction to side, angle, side and hypotenuse leg. In the next video, I'm going to go ahead and go through some example problems in the book. I'm probably going to do either all the evens or all the odds, or I'll mix it up. All right. And also, if you have any homework questions or would like further math help, please subscribe or leave a message in the comments section, and I'll get back to you and give you word for word answers, or just give you any kind of math questions or help that you need. Thank you, guys.